A common problem you're asked to solve is understanding the motion of a box on a slope. So here I've drawn a slope. They'll always give you the angle of that slope, and that's going to be very crucial in our formula. So first let's just see how you draw a free body diagram of a box on a slope. We know that regardless of the slope, the gravity is going to act downwards, and that's a given no matter what. So you can always draw immediately a straight arrow downwards. Now let's think about the geometry of this problem and start to see some relationships. We do know that normal force is going to be perpendicular to your surface, so what we should do right at the start is to draw that perpendicular axis. And when I say perpendicular, I mean that this angle is 90 degrees. And that's just a fact of where we place this axis. So now we can start to see some geometries. Here you have a small triangle, which makes this angle 90 minus theta, right here. And so we can figure out this angle and see that here we've made a perpendicular angle. So we can call this 90 minus this angle, which is 90 minus theta. And that equals, well, theta. So that's how you establish that relationship. When you do a problem like this, you should draw the vertical gravity and then instantly make this axis, and without having to go through these steps, you should just put theta right here between the vertical line and the axis of your normal force. And then make that a given in your problem, but you can understand how you got there from geometry. So once you've created this angle, let's say we want to draw the normal force line now. We know that normal force is going to cancel forces in this direction such that the box doesn't leave the slope. And that's why it's perpendicular, because it really depends on you trying to limit movement in this direction while allowing movement down and up the slope. So normal force is derived from every other vertical force, or every force in that direction, so we need to find that force. And then we can see here that it comes from gravity, so we need to break gravity into two components. We've been thinking in this coordinate plane, and these kind of problems require that you switch to this plane. So if we had a force going vertically, we're going to now break it into what component of that is going in this direction and what component is going in this direction. So we're going to do that right now for gravity. We see that we've created a triangle of your own right here, where this is perpendicular. And we want this to be perpendicular because we're breaking this component into directions this way and this way. So that's why we've created this new axis here. It's important to realize that this is now a triangle where these legs create the hypotenuse. So this vertical line is the hypotenuse of this shifted triangle. And so that's why we can create components, because this component squared plus this component squared equals this component. So we're not adding new forces to this equation, we're replacing this one with two smaller ones that still equal that one based on vector addition. So how do you write these? This one is going to be mg, using trigonometry. If this value is mg, then this leg of the hypotenuse is going to be mg times sine squared, sine theta. And then this component, I'm just shifting these out so you can see it clearly, is going to be mg times cosine theta. So when you do a slope problem, you have to instantly draw your free body diagrams, place the theta in the right location, and then rewrite your mg to these two components. So actually what you can do now is completely erase this one, and then draw normal force and two components of gravity separately. This component, mg cosine theta, and this component, so we changed its location, where we knew it was down here originally to make this line. We're just going to get rid of all that and write it up here as mg sine theta. And now it's so much clearer as a diagram to understand exactly what's happening with this block. it has a component of gravity this way, which is now being exactly equaled by n, which means we've cancelled all motion in this direction. And now it's only this component of gravity, a small portion usually, because sine theta is usually small. And that's the only component that's giving this block force in the direction of movement. This is the only direction that it's free to move. So this ends up meaning being ma, which is going to give you your acceleration down the slope.